Hi, my name is Sashrika Das. I'm an 8th grader from Eastline Middle School, and this is my device, Smart Trash Buddy. So here my device, here's the battery, and this is the microchip is an AVR board, and underneath my sensors are an accelerometer and a time of flight distance sensor to tell the distance of how much trash there is in my trash can. And the accelerometer is for detecting if the trash can has fallen or not. And here's the hole too for the distance sensor to get the data. And this case I also designed myself and printed. Now, alright, so speaking about the software part, there's a SIM card that's inside the microcontroller. And so here you will see in AWS the data being published over here. And here's kind of the architecture of AWS. I still have yet to complete this, but this will be finished before I submit my project. So here I'll connect to a cellular network, and from IoT Core, it will get the data, and IoT Rule will call the Lambda to send the data through AppSync, and then AppSync will then send it to my dashboard up at the top here. So I programmed my board using Arduino IDE. And so this is my code, and it will be updated in my hackster. So every minute, I programmed it to send the data every 1 minute to my dashboard. But it actually should be, depending on the situation, about like every hour. And so what makes my project different from others' projects previously in the past is that instead of just sending data to the cloud and sending an SMS to the authorities, it's an end-to-end solution that will give the authorities a solution and help optimize the routes to make trash pickups more easier and time and energy efficient. Alright, so here's the device, and I attached a little magnet here and inside the trash bin so it'll be easier to attach. Alright, so let me close that, and I will show you the dashboard that my dad helped me make. Alright, so we have to first sign in. Alright, so it was really cold outside, and it also started raining too. So I moved into the garage, so I'm going to continue explaining on the dashboard. So here's my dashboard that my dad helped me build. So after I attach the device to the trash can, it will be sending the data to the cloud and to my dashboard. So
Yeah, and let me bring it out so
Right.
that you can explain it better.
right.
Yeah. Okay. So I'll be holding like this for now, and you can explain.
The data is being transferred to the dashboard. It'll give a little notification here to know that it's been updated. And you can be able to tap on it and see how much trash is remaining, battery, and if it's fallen or not. If your trash can is less than 50% filled, then it will have a green trash can to filter out that doesn't need to be picked up immediately. But if it's over 50%, that will be labeled as a red trash can. So through our algorithm, to be able to optimize the route, it will be quicker and easier to be able to get to the houses that need trash pickup faster.
Right.
All right, and here there's a little error. So that's basically kind of showing that the trash can has fallen. So that would be nice to know whenever there's a trash that's fallen and there's no one around, so you can be able to take action on that.
Yeah, and that's because I'm just tilting it to simulate that situation.
Right. Alright, so now the main thing about my project is that after it reads the data, it will optimize the route to pick the shortest route possible. So you can see here the green trash cans are simulated for trash cans with low trash, and the red trash cans mean they're in need of a trash pickup. So in order to simulate optimizing the route before the trash pickup day, I made a little button here to simulate a trash pickup map. So as you can see here, as I explained before, it filters at the green trash cans, and it will take in all the red trash cans to pick the smallest route. And here, it will have all the numbered houses, and it will tell you all the how long it will take for to get to each house. And here's the notification pop-up. So this will usually be done the day before a trash pickup. Alright, so I'm going to talk really quickly about the route optimization algorithm. So here's basically metrics, but first we have to filter out the trash with greater than 50% empty. And then with the ones that are more than 50%, let's just take this as an example. So
And you get this data from AWS location service, that matrix, right? And then
Right.
on top of that, you are applying your algorithm.
Right. So let's say the numbers on this side here, for example, are different house numbers, okay? And the numbers inside are basically the distance between each of the houses. For example, say house 2, it'll obviously be like 0, let's say miles from house 2. And from house 2 to house 5, it'll be 120 miles. And then house 2 to house 3, 177, and so on, completing this whole metrics from house 2 to house 6. So basically, if you can, so let's say house 2 is our starting point, let's say. So we have to figure out which our next house will be, which will make it the fastest route. So 84 will be is the lowest number, so we have to go to house 4 next, right? And so from house 4, we can take out house 2 because we already been there. So the second fastest route will be 47, which will be house 6. So after we go to house 6, we won't need house 2 or 4. So then the quickest route, quickest route is route 4, but we already been there. So the next quickest route will be house 5. So let's go to house 5. And then after that, the quickest route will be
I think 3 is the only remaining.
Right, 3 is the only one remaining. So we just automatically go to 3. And then from there, we've been to all the houses. So then we just go back to the origin. So after we're able to figure out the sequence of the houses, in our dashboard, it'll show the proper sequence of each house for the trash delivery. Alright, so I really hope you like the project, and I hope to see this used from being a prototype to an actual product, and hope people can make this as a better prototype than it already is and enhance it further.